In this video, let's take a quick look at how to perform a LookAt over time. So Unity provides a transform.lookat method which performs an instantaneous LookAt. And what we're going to do here is try and stretch that out so that it doesn't perform that LookAt instantaneously, but it performs it more rapidly, more slowly over time. So here I have constructed a turret, and I have a cube that I'm able to drag around this platform here, and the turret is going to look at this cube, so it's going to follow it. And let's look at how the turret is constructed. So over here we have the base game object called turret, and then we have two cylinders as child objects of that base object. So the first one makes up the barrel to the gun, and the second one makes up the base. And I have them constructed so that the base is centered exactly on the parent object at 0, 0, 0 with no rotation. And then you see that the barrel is a little off center, so that the actual the loading end of the barrel is kind of on center with the parent game object, and it's rotated obviously to make it go off in the x-axis. Okay, then on the base turret we have this LookAt slow. That has a target, which we've set as the other cube, and it has degrees per second, which for now let's set to 720 degrees per second. So now I'm going to hit play, and we'll look at how it works. So we notice that as I move the cube, the turret follows it at 720 degrees per second. So let me increase this to 2000. And it follows it much faster. Okay, so all the magic here is happening in the LookAt slow script, so let's take a look at that. So here's the script. It's just a few lines. We have our transform target, and we have our float degrees per second. The first thing we do is create a vector 3 called direction from me to target. So this is going to give us a direction from the game object the script is attached to the target transform. And we do that very simply just by subtracting the target position, or taking the target position rather, and subtracting our position. So that gives us a relative position, right? So, and that's what is a direction essentially. So it takes our position from the world origin out of the target's position from the world origin, and what you're left with is the direction from us to the target. Then after that, I take that direction and I take out the y component. So I set that to 0 because I don't want to tilt up or down to look at this this cube. I want it to be on one plane. Okay. After that, we calculate a rotation where the forward direction would be this direction that we've specified, and there's a static method as part of the quaternion class called lookRotation that does just that. So we say quaternion.lookRotation, and we pass it direction from me to target, and it will align. It will create a rotation, so it returns a quaternion that where that rotation would have direction from me to target as its forward vector. So it would be looking at that in that direction, and it would be the quaternion rotation that represents that. So we save that as lookRotation. Okay, And then finally, we just have to update our rotation. So we have transform.rotation equals, and we use the quaternion lerp function to lerp between the two rotations. So we're going to start off with our current rotation, and we're going towards this look rotation, right? So lerp takes us and gives us a linear interpolation from one thing to another. In this case, it's a quaternion. So we have our current rotation, the target rotation that we're going after, and then the percentage of the way from 0 to 1 that we're going to go along that. So we have degrees per second over 360, which is our rate, and then we multiply that by time.delta time. Okay, and that's it. That gives that script allows us to follow a target at a certain rate rather than instantaneously look at it.